A black hole is born. It's 1 million times the mass of the Earth, but compressed so tightly, it literally exits the known universe.
Now, the effect of that mass is still in our universe. The mass is still here in that it's causing this fold in space that goes all the way down. It's become a hole. The best way to look at it is, if you stick your finger down in there, you ain't getting it back.
We know exactly what effect a black hole is going to have on its environment, on the stars in its vicinity, on the gas that wanders a little too close. So, will we ever see a black hole? No. But that's not what's important here. What's important here is we can see its paw print.
In search of a black hole's paw print, Eric Becklin is on a lifelong quest to probe the center of our galaxy. The Milky Way is a giant spiraling disk of over 100 billion stars. Our sun is about halfway out, in the peaceful suburbs. Becklin is headed to the galaxy's most exciting and most violent zones. But to make the final leg of the journey, he would need help. So he turned to a rising star in astronomy. Andrea Ghez believes that the key to finding a black hole at the center of our galaxy lies in tracking the stars that buzz around it.
For about 3 decades or so, there has been this question of whether or not our galaxy harbors a supermassive black hole at its center. And the key to answering this most definitively is to watch stars at the center of the galaxy orbiting.
Gez's team set up at the newly built Keck telescope on the summit of Hawaii's Mauna Kea volcano, the largest telescope ever built.
Our view to the center of the galaxy is absolutely superb. Our ability to position stars at the center of the galaxy is like somebody in Los Angeles seeing somebody in New York be able to move their finger like this, okay, just 2 centimeters. That's the precision with which we can measure something that is 26,000 light years away from us. Madeline, we're ready to go?
The conclusive experiment to be done that really demonstrated that it was a black hole was to follow the orbits of individual stars very, very accurately and with the highest precision possible.
But the stars in the center of the galaxy were not the only thing Ghez and Becklin had to keep track of. Another group, working in the mountains of Chile, was hot on the same trail, led by Reinhard Genzel from Germany.
This guy here.
Yeah.
It's a little too dense to be just a random collection. We suspect that in the galactic center there may be hiding very massive black holes. To really be sure that they are black holes, we have to go in there as close as we can, so we can make measurements really good enough now that we can say it must be a black hole.
Both teams wanted to be the first to prove that our galaxy harbors a supermassive black hole, but Genzel and his team had a 3-year head start. The amazing precision of Keck is the ace in the hole for Ghez and her team. Mark Morris is a veteran of the Galactic Center search.
The German group had already started to make headway on the Galactic Center even while we were deciding to pursue this. So we knew that in a head-to-head competition that as long as they were using the small 2.2 meter telescope that they were using compared to our 10 meter telescope, that we would blow them away.
Bright speck on the top of this inset. That's the star which really has given us the essential clue for the black hole.
It was certainly high excitement, but on the other hand, we would have to compile like at least 5 years of data before we could see the stars move.
But what kind of cosmic monster was pulling the stars along?